Okay, I'm just talking for the benefit of the video. So solving quadratic equations by factoring. We've learned to factor quadratic trinomials of the form x squared plus bx plus c, ax squared plus bx plus c, and difference of squares a squared minus b squared. And these are kind of the warm-up ones, and I'm just going to scroll this down so that the factored form is there, and then see if you agree or not. Okay, so for any of our viewers out there, these are the answers. And of course, if you're watching a video like this, you can pause this and look through it, right? And then, you can come into Wise Time and ask questions or throw a comment up or something on YouTube, which I occasionally see. But for, this one, the strategy is, again, let's solve a simpler problem. So we're going to let a equal x plus 5, that quantity. Then this becomes a squared minus 2a minus 48, which we factor. And then we replace the a, because that was never the original question, with x plus 5. And I like to keep this in brackets. Right? Then remove the brackets, collect the terms, and we get this. And this guy, let a equal 2x plus 7. Now, if you kind of look at this, when you think, when I square this, I'm going to end up with a 4x squared, right? And that's going to be the only square term. That's multiplied by a 3, so I'm going to end up with 12x squared as my first term. And if you look here, you're going to get 3x squared times 4. I'll end up with that 12x squared, right? So it's kind of a way that you can do a little bit of checking, is to say, hey, this is going to give me 3x squared, that's going to give me 12x squared. This guy's going to give me a 4x squared, and the 3 is going to give me a 12x squared. Okay, so we go through. And again, keep stuff in brackets. Okay, you can't, mathematically incorrect if you just write 3 and the next to it a 2x plus 7 without putting the parentheses around, right? And collecting. And then this guy is a difference of squares, kind of same deal, right? A quadratic, I would just hate this. It's not like it's not on your paper. Oh, wait, okay. Well, it fades to white. A quadratic equation is an equation that can be expressed in the form ax squared plus bx plus c equals 0. Right? So it's equal to a number. That's what makes it a quadratic equation, as opposed to y equals ax squared plus bx plus c, which we know is the curve, right? And what did we do last unit? We did y equals ax squared. We're looking for what's the vertex of this curve. What are the x-intercepts of this curve? What's the y-intercept of this curve? Here, we're saying, well, really, what are the x-intercepts, right? It wasn't recording. Crap!
The entire time.
Hang on. While you work on this problem, I'm going to go back and re-explain the last sheet. So you just work on this. I have no idea where this left off, so I'm just going back to the beginning. All right, I'm pretty sure we recorded this. So we recorded 3 minutes of how long have we been doing this? Blah, 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 zero product property, blah, blah, blah. God, no idea. This I know we did record some of. Okay. You work on the problem while I explain this to our viewing audience, or whoever's not here today that should be.
Yeah.
Factor this, then you say either x minus 8, either this factor is 0 or this factor is 0, in which case x is equal to 8 or x equals negative 2. You can check this. It would be 64 minus 48 minus 16, which is 0. Very new info. Right, or it's 4 plus 12, which is 16, minus 16 is equal to 0 with this one. To solve by factoring, you must have a quadratic equal to 0. We then factor, we set each individual factor to 0, and we can list the solution as a solution set consisting of x is equal to, must be brace brackets. If you put parentheses around, it's an ordered pair, and it's wrong. And here, we're only getting 2 terms. It's still a quadratic equation because it's got a square. That's all you need to be a quadratic equation, is you've got to have a squared term. Okay, we don't need a constant. So in this case, it's common factor. Take the x out. Either x is 0 or 3x minus 5 is 0. Solve. And you can leave your answer like this, right? We have the 2 solutions. X equals 0 or x equals 5/3. And here we are, back with this. So you guys are working it. Now I'm going to start working it, and you can compare, right? Also compare with each other, right? you can help each other out, right? By doing this, and you know, maybe you're just checking other people's work and that. But if you see a mistake, let them know. So the way to expand this is to always multiply out the binomial first, keep the 3, multiply this out. What's it going to be? Keep the 2 minus 2, square this. Okay, so that is step 1. Okay, I'm going to multiply the 2 binomials, collecting terms. I'm not going to show you the 4 products. We know there are 4, right? I don't do that. You may, if you like, I don't care. Write out the 4, then collect it down to 3. So either that's your next line, or you have a line in between which goes x squared plus x minus 2x minus 2. And then your next line is x squared minus x minus 2. Expanding these, you got to be very careful, right? So the first one, pretty easy. It's just 3x squared, nice squared, minus 3x minus 6. Okay, now, minus 2x squared. Negative 2 times negative 2 is plus 4x. Minus 2. Minus 4. That's just this guy. It's been along for the ride up until now. Okay? Yeah, and hey, if you notice a mistake, speak up sooner rather than later. Now we're going to collect together. I've got 3x squared minus 2x squared is x squared. Minus 3x plus 4x is plus 1x. What?
2x minus 1, not 2x plus 1, so then it would be a negative 2 would be positive.
Which line?
Like go on the second line, so from the first line it was negative 2x
So you see this
minus 1 squared, and then you squared it.
X?
You squared it, that's why. Okay, never mind.
Yeah.
I this for myself.
When I FOIL stuff out, I always collect the middle term in my head, because I don't like writing out 4 terms, and I figure, yeah, usually when you're squaring sides, it's pretty minor arithmetic, just watch your signs.
Yeah.
Okay, so x squared plus x. Okay, so I got minus 6 minus 2 minus 4 is minus 12. Oh, and one thing is, don't lead off with an equal sign here. Okay, so you notice I start off by writing equal signs because that's an expansion, but this is an equation, so you only want one equal sign, right? So if this wasn't equal to 4, then I would write an equal sign on the left-hand side to say, hey, this is this expression, and I'm simplifying it. I'm not. I'm solving an equation. So this is equal to 0. Okay, now we factor. X, need a bigger plus than a minus. Then I check x squared. Minus 3 plus 4 is plus 1 minus 12. It's all good. And the solution set in set notation is that x is negative 4 or positive 3. Okay, so just for the heck of it, let's check the 3. 3 minus 2 is 1. 3 plus 1 is 4. 3 times 1 times 4 is 12. 3 minus 1 is 2. 2 squared is 4. So I've got 12 minus 2 times 4. 12 minus 8, which is 4. Woohoo. Right? Now, that's a mental check. You could do it by punching in your calculator, going 3 bracket, 3 minus 2 bracket, 3 plus 1 bracket, minus 2 bracket. I just fill this in exactly as it stands with the 3. Hit enter, you should see 4. Copy the line down on your calculator, put a negative 4 instead of the 3. Hit enter.
Why is it negative 4 and 3?
Because I need x plus 4 to equal 0. So what value x? Okay. So here I'm just kind of cutting to the chase, right?
Yes.
Now, I could also do that here. So what's the quick way of solving this for 0? So here's the slow way. So the slow way says, take this 5 and move it over. And it's going to change signs, right? Change sides, change signs. then divide by this number. So to do it quickly, just say, change the sign, that's positive 5 divided by 3. Just write your answer down as 5/3. I don't need to see this work. Okay? I just need to see the solution. 0 and 5/3. Now, if you're doing it that way, write that down, as you're doing your homework, you write it down, 0, 5/3. You check the back, it says 0 and 5/3. You're happy. If you get this one wrong, then do it a little more detailed, right? Like show that work. So you have to decide how much work you need to show in order to get it right. Right? So it doesn't mean we're all doing it the same way. We should all be getting the same answer, right? But we don't all have to do it the same way. So you work with what's comfortable for you. Oh no, it's a thin line. All right, either we hurry through it, but it's going to disappear. Okay, I don't know about you, I do not like denominators, but the nice thing is it's an equation. So, what's the lowest common denominator? Or if I multiply everything by what, how can I get rid of all these denominators? Multiply by 10, right? Multiply everything by 10, 5 goes into 10. So this becomes, oh man. Don't worry, I'm going to rewrite this all as soon as the writing disappears. Okay, did you get that? Watch one more time. So, think of it this way. If I multiply every term by 10, the 5 will go into the 10. I'll get rid of the 5 in the denominator. And this doesn't have a denominator, so let's just write it over 1. So let's give it a denominator. Right? So what I'm multiplying by is the lowest common denominator, right? Which is going to be a 10. So I go 10 over 1 times 4/5 x squared is equal to 10 over 1 times x over 1 plus 10 over 1 times 3 over 10. Now, this might be the last time I show this way, right? Because I think we can make the leap to, okay, if I multiply everything by 10, I'm going to get an 8 here. I'm going to get a 10x here, I'm going to get a 3 here, or whatever it is, right? But this is the idea behind it. So 5 goes into 10 twice, right? 5 goes into 5 once, into 10 twice. Leaves me with a 2. I got 1s here, that's good. I don't want, so my objective is I need every denominator to be a 1. Okay? Once it's a 1, then we're good, right? We can solve it. So here, 10 goes into 10 once, and into 10 once. Okay? I've done the same thing to each term. I didn't go through and say, hey, I'll multiply this one by 5. I'm not going to do anything to this one, and I'll multiply this one. That's not equality, right? Equality is the scales of justice or balance. And if you multiply this by 10, then you multiply that by 10, and they still stay in balance. Okay, what do we get? 2 times 4x squared is 8x squared is equal to 10x plus 3. Okay. Now, what I would do solving this is I would go from this line to this line. Just saying, hey, I'm going to multiply everything by 10. 5 goes into the 10 twice, gives me a 2. 2 times 4x squared is 8x squared. I've just got an x, I've got to multiply it by 10, 10x, and I've got 3 over 10 multiplied by 10, I get a 3. So I'm okay if you go from this line to this line. I'm okay if you go from this to this to this. And yeah, I don't really care. If you end up with this, it's all good. Okay, then, well, we go 8x squared minus 10x minus 3 is equal to 0. Factor it by whatever method you like. Okay? I don't care how you factor. I just want a correct factorization. And I want you to check that the factorization you actually have is correct. Okay? So on 2 things. I have no idea, so this is my starting idea. happens to be right, but what the heck? I mean, that's experience. And it's not written very well. Okay, now I'm not even really sure if that's right because I went to 8x squared minus 12 plus 2 is minus, okay? You're going to be slower at factoring than me, likely. Doesn't matter. What matters is you get that as a factorization. And now you write down the solution. Change the sign on the 1 so it becomes negative 1 over 4. Change the sign on the 3 so it becomes positive 3 over 2. That's your answer. Those are your answers. Not that your answers. Or, that's not how I roll, you say. So I know that either 4x plus 1 is equal to 0. So 4x is negative 1, and x is negative 1/4. Or 2x minus 3 is equal to 0. So 2x is equal to 3, and x equals 3/2. A little comma in between them, but all right, you need to do what you're comfortable doing and what will give you the correct answer. Okay? So if I'm saying, if that were the question and I were marking this, then what are the steps I need to see? Right? So you're asking, what's the minimum I can do? This, 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 and this. That is the least amount of work that you can do for full credit. Okay? So we're taking this and we're writing it just in a form where we don't have denominators anymore. We write the quadratic, we give the factored form of the quadratic, and we give the solution. Okay? Nice, easy, flowing, right? How much more you want to show, need to show, whatever, do what you need to do. If there's not enough room on the page for you, you write large or something like that. Ask me for foolscap. Do all your solutions on the foolscap. Make sure that it's very neat and it's numbered and attached. We'll staple it on. I will mark the foolscap. Okay? So, otherwise just learn to write a little bit smaller and squeeze the stuff in. Whatever works for you, right? If you don't write, but don't hand me a mess, right? We were looking at somebody's paper from the Math 31 class and it was like, there was erasing and there was stuff crossed out and it's like, you can't follow it, right? It's garbage. I don't want to see garbage. I said, give the kid foolscap and just say, write out a nice solution. Okay, erase things that you don't want to be there. Give me a nice, clean, logical solution, right? So I just want to be able to follow something through that's mathematically correct, right? And if I don't think you can do it in enough steps, but I figure you understand it, I'll just say, let's show a little more work. Write a quadratic equation with roots of negative 2 and 5/3. Express it in the form ax squared plus bx plus c equals 0, where a, b, and c are integers and a is greater than 0. Okay? So generally speaking, standard form is defined as ax squared plus, or maybe that's general form. General form is ax squared plus bx plus c equals 0, where a, b, and c are integers, so we don't have the fractions like we had in the last one, right? And a is greater than 0. You're leading with a positive x. So here's what we do. Actually, let's go back a bit. These are the roots. These are the factors which correspond to these roots. So I'm going to show you how you go from a root to a factor. So what we're doing basically in the next question is we are taking this and going to this and going to this and forget anything up there exists, right? Like you're not going back to that. That was some artificial construct, right? So we are taking this and going to this and going to this, and that's where we're stopping. And we've got the blue circle of death, where it's spinning nothingness. Yeah, so we will pause while this. Given the roots. Declan, pay attention so you can explain this to somebody else later. Given the roots. Yeah, I know. But it was a nice way of saying, stop talking. All right, so what do I know? I know that the root is -2. Hey, wait, it just went back, right? You delay enough. I want the factor. To get the factor, we want to have some expression here is equal to 0. How do I make this side 0? Add 2. If I add 2 to this side, what do I do to this side? Add 2. Really what I'm thinking about is just get rid of this, right? You switch sides, you switch signs. So x plus 2 is equal to 0. Guess what this is? It's a factor. Now, what else do we have? X equals 5/3. So I'm going to have to do 2 steps to get this to be 0. What's the first step? Multiply both sides by 3. 3x equals 5. So then what? 3x minus 5 equals 0. This is the root. What's this? That's the factor. So I'm going to take the 2 factors, right? X plus 2 and 3x plus 5. And I know that that's equal to 0, right? Because if x is -2, this expression becomes 0. And if x is, that's a minus, not a plus. And if x is 5/3, 3 times 5/3, the 3's cancel, 5 minus 5 is 0. What am I going to do with this? Foil it out. So this is 3x squared. This is minus 5 plus 6, which is plus 1x. This is minus 10, and this is 0. This is a positive x squared. These are all integers. This is the general form equation. If you want to check this, then on some other piece of paper, you can take this, factor it to this, and get the roots out of it. Okay, but keep in mind, what are we doing? We're starting with roots. What's the root say? It says if x is equal to -2, then that expression will be 0. Well, if x is equal to -2, then x plus 2 is the factor which corresponds to that root. Same thing with 5/3. So basically what you're doing is write it as x is equal to the root and change it so that the right-hand side is 0. Then you now have a factor. Take the 2 factors, put them together, FOIL it out. Okay, questions? You're going to need to do a few of these, right? Otherwise, you're just going to sit down on the test and go, I remember seeing that, but at this point in time, I have no idea what happened with it. And then you'll write me a, I remember seeing this, but at this point in time, I have no idea what to do. Please take pity upon me. Surely this essay must be fine $20 bill attached. You know, it's okay to write out, because basically at that point you're communicating with yourself. Because I got bored with there's nothing here for me to mark, right? But I will read it. But communicate to yourself and just say, I don't know how to do this, and this is something I'm going to have to look over before the cum, right? Because remember, anything we do, you're responsible for, right? Because you're going to see it on the final. You're likely to see it on the unit test. You're likely to see it on a cum exam. Okay, so it's not I suck at quadratic functions, so I'm just writing it off for the year. Because you can't, because it's going to be on the cum. Half the cum is quadratic functions. If you don't know them now, you need to learn them before the cum. Okay? You need to come in during wise time. You need to sit down. You need to go watch a video. I don't care if it's my video. There's nothing special about them. They just happen to match the worksheets, right? So if you're looking through, if you don't get one of these, so let's say we do this and it's just like, yeah, I didn't follow that, but I didn't feel like asking in class. Then go home, sit down, fire it up, drag it to this spot, and watch it again. If it doesn't make sense after a couple of watchings, then come in and sit down and ask about it, right? Don't just, I watched it like 5 times, I still don't understand this. Okay. Usually, your misunderstanding is not as big as you think it is, right? You think it's like, oh, I've got a clue how to do it. It's like you've got one little point that has to be tweaked, at which point you go, oh, now it makes sense. If you never bother trying to tweak that one point, then you're just going to go through and just say, none of this makes sense, right? It's not usually a big thing. Anyways, two numbers differ by 10, and the sum of their squares is 388. Determine the value of the two numbers. So, last sentence in a word problem is always the, this is what you got to find. Well, it's almost always. So what do we got to find? Two numbers. Okay, so let the numbers be what? All right, so x is always a good choice. What's the other number going to be? If one number is x, what's the other number going to be?
10.
Well, what do we know about the two numbers? They differ by 10. Okay, so if this number is 5, what's the other number? 15. If this number is 20, what's the other number? 30 or 10. This number is x, what's the other number? X plus 10 or your choice. I'm going to choose x plus 10. Are you sure? I'm positive. It doesn't matter, right? What matters? So now here's what you do, right? So before you go and solve this, because if this is wrong, guess what? All the subsequent work that you're now about to spend 5 minutes on a test or 10 minutes on a test doing is wrong. That's not the worst of it. The worst of it is, depending on how wrong it is, it now takes 15 minutes to do something rather than 5 minutes, right? Because you just made a hash out of it, and the numbers really don't fit, and then everything that follows, not only is it wrong, but it's really difficult to do. So you don't want that. So all you do is now you just say, okay, if that's 20, that's 30, and the two numbers differ by 10. Okay, I'm good. The sum of their squares. So how am I going to write the sum of their squares? So the first number squared is x squared. Plus what? X plus 10 quantity squared, right? Do not write this. Okay? You write that, that's wrong, right? I mean, that's x plus 100. So remember, it's... And what's that equal to? All right, right? So that's what we got to do. We have to translate English into math. Right? Two numbers differ by 10. So you try the two numbers, then you try different numbers for them. You say if x is 5, 5 and 15. Okay, those differ by 10. What if x is negative 2? Like a negative 2 and 8. Okay, they differ by 10. Right? Now what? The sum of their squares. Sum is add. Product is, quotient is, divide, difference is subtract. Okay? So this is easy, right? Sum. The sum of their squares. Okay, so I got to square them. And the x plus 10 is a quantity. So it goes in brackets, right? Because it's not really x plus 10, right? It's really 15. If that's 5, this is really 15. Okay? So I want to square 15, not square the 10. Okay. So now you expand x squared plus, expand this. Get rid of the 388 from the right-hand side, move it over to the left where it changes sides, then it changes signs. Select everything together. So I got 2x squared. Because I know how to square x plus 10 in my head. which hopefully I did right, or I'm just going to come off sounding like an idiot. Okay, I don't care how or why or whatever method you use to square x plus 10, but x plus 10 quantity squared. If you write x squared plus 100, I'm going to put a big X through it and deduct 3 marks from your solution. Okay? You may not square a binomial and get 2 terms out of it. That is an unforgivable error, at least in my book. Okay? So now you know. You see x plus 10. So I'll do it for you down here. We're going to erase this in a second. This is what I see all the time. Okay? That's wrong. So here is the full explanation. When I square something, I multiply it by itself. When I do that, I use FOIL. When I use FOIL, how many products do I get? No, I get 4 products, which will collect into 3 terms. But I get 4 products, which are x squared plus 10x plus another 10x plus 100, which becomes x squared plus 20x plus 100. Now, I would prefer you did this on a separate sheet of paper, which you attach showing all the work, because you say, I can't square a binomial in my head to save my life. Okay? Does that mean you can't square a binomial? No, it means you need to show more detail. I look at this and I write that. Okay? Because remember, we did, it's called a special product in Tensor. We look at special products and say, when you're squaring a binomial, what do? You square the first term, you multiply these 2 guys together, 10x, and double it, and you square the last term. Right? That's the quick way. If you're comfortable going from here to here, do it. If you go from here and you write x squared plus 100, I'm putting a big X through there and I'm deducting all the marks on the question. Right? So everybody understand? You square a binomial and get 2 terms, you're going to lose all the marks on the question. Yeah, it's tough, too bad, so sad. But you know, right? I can rewind the video and just say, all right, look, at 32 minutes in, the explanation came. I do not forgive that error. Okay? You may not make that error. You can make lots of other errors. You make that error, it's going to cost you all the marks on the question. Okay? Everybody good with that? I mean, you don't have to be good with it. You can say, I disagree with you. And too bad. Because I'm the one marking it.
I can see why you enjoy teaching.
Yeah. And I told you. So, really, I can't emphasize it enough, because seriously, I see this stuff in Math 30-2. I see it in Math 31, right? Like, you know, your brain goes for a moment, you square that, and you get the 2 terms. It's wrong. The bridge is going to fall down because you can't square a binomial, right? So we don't want bridges falling down. All right. Now, nice thing about equations is, you notice all those terms are even? So we could factor out a 2. We're not going to factor out a 2. We're going to divide everything by 2. What's 2x squared divided by 2? What's 20x divided by 2? What's 288 divided by 2? What's 0 divided by 2? So the nice thing about solving equations, right, it doesn't work. If I say factor and I give you the left side is not equal to 0, there has to be a factor of 2 in your answer. When you're solving an equation, since it's equal to 0, if you notice a common factor, you can just divide it out. Because 0 divided by anything is 0, except for 0 divided by 0. Doesn't exist. But you look at that and you go, hey, everything's even. Great, let's divide everything by 2. Keeping in mind that this is an equation, and because it's equal to 0, I can do that. If this were an expression and I was factoring it, then I would need the 2 as a factor. Okay, got that? That won't cause you a loss of all the marks, right? Only squaring by. Okay, so now here's the deal. This has to factor because the numbers have to be numbers, right? It's a number. So it's not like 12.2 or something. So, all right, what is it? It's like 12.
18 and 8.
Yeah.
18 and 8?
Yeah.
Yeah, okay, that's cool. So it's got to be an x plus 18 and minus 8. Okay, so I don't know how you found the numbers because I was still working on them, but you know.
I just guessed one.
Yeah, exactly, right? Hey, guess and check. Now, big thing to do. Let's check this because what's likely, okay? You found the 18 and 8, you've done the heavy lifting. So why mess everything up by getting the sign wrong? Okay, so x squared minus 8 plus 18 is plus 10. Good, everything's good with the world. And then 18 times 8 is 144. Cool. So what's my solution? What's the solution to this one? X is equal to negative 18. Or x is equal to 8. Are we done?
Yeah.
No, because the question said, what are the numbers?
Dang it.
Okay, determine the values of the two numbers. Now, how many sets of solutions do we have? 2. Because the numbers are not negative 18 and 8. Those do not differ by 10. They differ by 26. Okay, so this says the first number is negative 18. What's the second number? Negative 8. Okay, so here we go. The values of the two numbers are negative 18 and negative 18 plus 10, which is negative 8, or 8 and 18. Now, George Polyev, famous Hungarian mathematician, the four-step problem-solving method, which is understand, plan, do, and look back. The look back part of this is, what's negative 18 squared plus negative 8 squared? Now, if you're going to do this on your calculator, you're going to have to go bracket negative 18 bracket squared, because if you type in negative 18 squared, it's going to give you the negative of 18 squared. All right, so if you want to check on your calculator, you got to do this. Not this. Right? Because this is, what's 18 squared? Like 364 or something? I have no idea. Yeah, 364. So this is 364, and this is 24. See, I told you I had no idea. Yeah, actually, it would have been a heck of a lot easier just to square the 8, subtract that from 388, and then figure it out. It must be whatever.
Why does that make a difference, though?
Well, because that's negative.
Yeah, but
Because the first one you're squaring the negative 18, the second you're not squaring it.
So we want to square the quantity negative 18. When you square a negative number, what do you get? A positive number. So this is incorrect. Okay? So you don't do that. Your calculator, here's how your calculator works, right? Calculator does order of operations. What's order of operations? What's the theme for order of operations? Bed mass, brackets, exponents, division, multiplication on the same level left to right, addition, subtraction on the same level left to right. It's going to do brackets first. So this is going to take the brackets and then do the exponent. So it's going to take negative 18 times negative 18, which is positive 324. This is going to do the exponent first. It's going to square the 18, and then it's going to multiply it by negative 1, because you're really saying it's a negative 1 times 18 squared. So it's going to square the 18, and then it's going to make it negative, which is wrong. We don't want that. Okay? Anyways, if you square negative 18 and you add the square of negative 8 to it, you get 388, and if you square 8 and square 18, you get 388. Okay, what? One left?
Yeah.
Okay, so in solving a word problem, you need like a let statement, right? You got to clarify to people what are the numbers, right? Let the numbers be x and x. An area rug has a central 5 meter by 3 meter rectangle and mosaic pattern with a plain border of uniform. Oh my God, it's not going to be. Yeah, I know. It's just I get to redo the diagram in a moment. Okay, so central, a plain border of uniform width. Okay, so here's the border. Uniform width means that it's, well, no, it's rectangular. So what does uniform width mean? It means this and this and this and this are uniform, which is a way of saying the same, right? As opposed to uniform, which like the police constable wears. It's different uniform. So uniform width means the same width. Okay, this is a really common type of question, which you are going to see on the test and on the cube, and see disappear in front of your eyes. But you're going to see this type of question, right? So it will be phrased as a rug. A pool has a deck of uniform width. A picture has a frame of uniform width. Okay? This is an extraordinarily common type of question. So we've got 3 meters by 15 meters, and we've got this uniform width, okay, of x and x and x and x. So that's what I mean by uniform width. It's the same width all around, right? You could use W if you like, if you're into W's for widths. Okay, the total area of the rug is 24 square meters. Okay, how big is this? What does this measure?
5 plus 2x.
Okay, so we've got 5 plus 2x. How big is this? 3 plus 2x. Did I mention you're going to see a question like this on the forever, right? Don't be surprised if on the final, I can't remember what the final looks like, but do not be surprised to see this. Find questions in the book that look like this, even if we don't assign them. Okay? It's a very common type of question. Okay, what do we know? The total area. What's an expression for the total area of the rug? We know it's equal to 24, right? Okay, what's equal to 24? What times what?
2 and 12.
This times this. Seriously, and 1 and 24, and 24 over 7 times 7.
Yeah.
Don't take me too literally. You're right, that's kind of funny. Are we going to finish on time? Oh, plenty of time. Yeah. We're not full, right? Oh, wait. No, wait a second. It's Wednesday and Thursday. We go 11:40. We got lots of time. Okay. So, right? This is 15. This is 9, right? Like, this is 15, right? Therefore, this area is 9. That's really hard to do, right? Because you don't want to figure out this and that, it's not like it's x times, we're not going there, right? We're just saying, hey, I know what the total length of this is, I know what the total width of this is, and I know that that product is 24. All right, multiply it out. So what do we got? 15. Here, I'll do the 4 products for you. Plus 10x, plus 6x, plus 4x squared. Now, I can either say equals 24, or I can say minus 24 equals 0. You got any preferences? Minus 24 equals 0? Okay. Now, let's put it in order, right? So we're going to lead with 4x squared. I got 16x, and I got minus 9 is equal to 0. Right? Because I've got 15 minus 24, which I believe is negative 9. Now we got to factor this, right? I'm going to assume it factors because we're in the section on solving by factoring. It's a good bet. Here's the thing. There's a really good bet that on the test it won't factor. You'll be using a different method. There's a really good bet that if it says rounded to the nearest hundredth, that it doesn't factor because otherwise, why are we asking it round to the nearest hundredth? Okay, so let's try and factor this. I am betting on this and 3s. 12, 15. Nope.
2x.
No, it's 2x.
2x.
Minus 1.
2x minus 1 and x plus 9.
2x.
2x. 4x squared plus 18 minus 2. Ah, good. Again, right? It might take you 3 minutes to factor that. Nobody cares. Right? Well, it's better if you're a little faster at it, but it doesn't matter, right? What matters is you can factor it correctly. Okay, so x is equal to 1/2, or x is equal to negative 9/2. Right? Yeah, it can't be negative 9/2 because it's a width of a, right? So in the context of the question, people still looking like, where'd you get x equals a half?
Oh, wow.
Yeah, so it's okay. Do you want to see where the x equals a half? You know, right? I don't mind showing it, right? So either 2x minus 1 is equal to 0, so 2x equals 1 and x is 1/2, or 2x plus 9 is equal to 0, so 2x is negative 9 and x equals negative 9/2. Okay, it's a width of a border, it cannot be negative. So negative 9/2 is a valid solution to this quadratic. In the context of the problem, it does not fit. So we reject it, but you must show it. So you've got to show, look, I have this solution, and then you're going to put an X through it saying, yeah, that's not the solution. And then you're going to say the width of the rug, because I'm pretty sure that's what it would have asked for. Determine the width of the border. The width of the border is 1/2 meter. It's a half of a meter. Don't forget the units, right? You get units, you can lose half a mark. You don't want to do that. Okay, now, hang on. There's still time. Jeez. First of all, hey, school clock's off by at least 1 minute, and it's 1 minute slow, so that means we have, 2 minutes. What's 5 plus 2 times a half? 6. What's 3 plus 2 times a half? What's 6 times 4?
24, yay!
Good. So your check is to go back here, forget everything you wrote, forget this, go back to this. If x is a half, this is 6. If x is a half, this is 4. 6 times 4 is 24. That matches up with the original question. It's all good. Okay, you're going to see this problem. It could be a pool with a deck of uniform width. It could be a picture with a frame of uniform width. They could mess you up and make this width double this width. But then they'll show it in a diagram, and your job is just to make sure that you get an expression for the total length and an expression for the total width, and then somehow come up with a quadratic and solve.
Just don't say anything on